So this section is going to be all about container image registries. And there's a lot to go through. So we're actually going to start with basically saying that you need an image registry in your plan. It's not really an optional part of the container ecosystem. The way that Docker and other tools are designed is that they need a place off your servers and off of your developer workstations to actually store your images. And technically they can be zip files and you can export and import them, but that's really an arduous situation. So you really want to plan for a registry, whether it's on the internet or a private one. So we're going to actually go through some things in different lectures here where we talk about the details of Docker Hub and some of the auto build options there. We're going to focus on the Docker Store for a lecture and how that's actually different than Hub. And then the Docker Cloud option, which is actually also different than Hub, but also an add-on to the Docker toolset and maybe could help you make it easier to deploy servers and your stuff into the cloud. We also have the new Swarms feature now in Docker Cloud that I'll have a specific lecture on. And then you're going to learn how to build your own registry and deploy it on either your local machine or on a Docker Swarm to use as a private registry. It's actually open source. And then we'll mention some of the third-party registry options in case you don't want to use Docker Hub or the open source Docker registry. So in this lecture, we're going to cover some of the advanced topics of Docker Hub. Now, it is the most popular image registry in the world for containers, but it's not the only one. So let's just see what it does in addition to what we've already discussed so far. In summary, Hub is a registry, but it also has image building in it that's not normally a part of, for example, the open source registry. And so it does have a little bit of extra stuff in it that allows you to build images on the fly. And we're going to jump into some of those features here and then also talk about linking your GitHub and Bitbucket accounts to Hub and checking out some of the auto build features for building your images based on the commits. And then we're going to show some features around chaining image building together so that you can make it easier to make sure your images are always up to date. So we've already covered a little bit about Docker Hub when we first learned about images earlier in this course. But I wanted to go through some of the other features that maybe we haven't discussed and then compare that to the Docker Store and then talk about what Docker Cloud might do for us before we actually get into other registry options for ourselves. Obviously, Docker Hub is a registry. It's what we've been talking about this whole course. It's how we pull all of our images, and it is the default registry for Docker, but it's not the only one by far. Let's talk about what it can do besides what we've already done. We can see that I have repositories here, obviously. You can tell that I actually have at least one private one here. The private ones, you get one free, and the rest you have to pay for. So you set up a billing account like normal, and you'd pay for that. When you create repositories, and on each one of your images, whether they're public or private, you can choose to give permissions to people. So this is what my view would look like for a repository that I own. This happens to be a public one. And if I went into settings, you can see that I can switch back and forth between making it private and public. I can delete it. I can create webhooks. And the webhooks are really handy for when your images are built and pushed into Docker Hub. You can have it send a webhook to some other service like Jenkins or CodeShip or Travis CI or something like that to have automated builds continue down the line. So those webhooks are there to help you automate the process of getting your code all the way from something like Git or GitHub to Docker and all the way to your servers where you want to run them. The collaborators is the permissions area where you can set permissions for other people to do things with your image. And then we also have organizations. So you have your own permissions for your own repositories, and then you can give others permissions to your repositories. But if you want to create organizations, you can do that as well. They're totally free. And for example, underneath this organization, I can see all of their repos. And then because I have the permissions for each one, I can actually go in and change all their settings. You can see that I can control team membership. I can control billing like you would normally do for private images. This is very much like GitHub. If you've used GitHub at all, if you've ever paid for anything on GitHub, it's very similar where everything that's open source is free. And then anything you want to be private, you have to pay for in group plans. And the organizations work the same way as GitHub. So there's not a whole lot else to it. I just want to show you a few key things that you need to know if you're going to start using it. One is if you're using GitHub or Bitbucket to store your code, don't click this button to create your repository. Also, don't do a Docker push before creating it first, because what you really want to do is go up here to create and create automated build. The automated build allows Docker Hub to create this CI path that will automatically build your image based on code commits. So this is like the reverse webhook. So the webhooks we just looked at a while ago are for Docker Hub to notify something else that it's finished with an image, but this process allows Docker Hub to be notified when something else happens. And I always set it up for auto building my own repositories. And in this case, for instance, I just chose a repository I have access to in GitHub, and then I give it a short description, and it allows me to create a repository. But in this case, it knows it's coming from GitHub. So anytime there's a commit based on certain requirements or certain branches, it will actually build my image on the fly. And then I get a nice little email saying it's successful or not. And that's why you see on a lot of images that they're automated builds. And that's just one indication of quality, because it shows that this image is likely always up to date with wherever the source code is. And you'll see here, like the Jekyll serve that we used previously in this course, that I have some of these automated options here that I didn't have in the previous repository that wasn't set up for automation. So here I have build details, build settings. So you can see that each time it's built, it's successful in the history, and then in the build settings, I can choose which branches I want to build. And something I highly recommend is that down here under repository links, if you are building images on Docker Hub and you're using a from statement that you're pulling from some other image, then you want to set up repository links here so that anytime that software changes, your image gets rebuilt. And that's a big deal, because over time, your image is going to have dependencies on it, and it's going to need to update when those get updated themselves, maybe based on security requirements or new bug fixes. And so on mine, because it's running Ruby and Jekyll inside my image, and its from statement in the Docker file is actually the Jekyll, I put those here so that anytime those images get rebuilt, mine will then get rebuilt. And if you also want to create a build trigger is another inbound way for you to automatically have an image be built. And maybe you have some other software that's not GitHub that you want to kick off builds whenever something happens. So you can create those unique post URLs there. So Docker Registry. We've previously discussed how it can be a registry that you store privately on your network. It's actually part of the Docker/distribution GitHub repo. So if you went looking for registry, just so you know, there's an old version of registry in GitHub that is legacy. It'll clearly say that. The current V2 registry that we're all using was rewritten in Go and can be found in the distribution code repository, but you probably won't use it from GitHub. You'll probably use it from Docker Hub. And Docker has a pre-built official image for registry, so it's as simple as Docker pull registry. And I would say that it's pretty much the de facto back-end registry for storing your containers privately. Now, it is pretty bare bones. There's no web GUI. It's definitely not like a Docker Hub or other third-party service. And out of the box, it does support certificates and basic authentication, but they're not enabled by default. And the authentication is actually everything or none. It's not RBAC or role-based access control. It's more like Apache HT access, where if you have a username and password that you get through, you have read-write access to everything. So it's probably only useful in small teams without some sort of tool on top of it to make it more enterprisey and scalable. But at its core, it's really just a web API and a storage system to handle all of these large images we're going to be dealing with. But the nice thing is it actually comes with a lot of built-in storage drivers that allow you to put the back-end storage of it on S3 or Azure or Alibaba or Google Cloud. And it's even got an OpenStack Swift driver. But we're just going to use the local, which is default. And basically that just means using the local file system in the image or on your host using volumes. So real quick, before we get to installing the registry, I wanted to bring your attention to a few of the resource links in this section that you should check out. The first one is a basic setup with TLS. so that you won't have to enable the insecure registry option, because obviously TLS is a good thing. The second is a reference article from Docker around garbage collection. So the thing about a registry is when you start using it in the real world, it really starts to take up a lot of data. And especially if you're pushing images over and over, it can really start to eat up disk space. And so you need to pay a little bit of attention to your decision around your storage driver, and as well, this article on garbage collection, which will try to clean up old things and keep your storage in check. And lastly, a really cool option is the registry mirror. So if you're deploying to production and one of your concerns is that you don't want to depend on the hub for a lot of your base images, then what you can do is a feature in Registry is to enable a proxy mode, and then you tell your Docker daemons to use the proxy, and what it will do is it'll cache any hub images inside that registry, which is pretty great if you're wanting to make sure that you can optimize your bandwidth in case you've maybe got dozens or hundreds of servers. You definitely don't want to be downloading the Ubuntu image on every single machine from the hub, right? So you could have this proxy much more closer to your metal, and then it also would provide some failover in case the hub would have issues. You could still get your copies of the images locally.